Okay. Wow. Here we are. The last section of the semester. I can't believe it. I can't believe it. So before I even start this, I'd like to personally say thank you very much for being an amazing class. Um, it is crazy how the circumstances laid out for us over the semester, but what I am just so grateful for is the fact that not only did I have all of you as students, but how together we persevered through the hardships of what's happening right now. Um, the way I look at it is, I really am appreciative of the fact that we have technology and stuff like that that still allows us to maintain some sort of normalcy throughout this entire ordeal. And for those who have emailed me and stuff like that, just to ask how I was doing or questions and stuff like that, thank you so much. It means the world to me. I did promise you a video of like my setup in the cats and introduce you to my wife Molly. So I will do that before the semester ends. So you will get to see that. All right. So don't think I forgot about that. But sometimes I just get so far into work mode that I just love working, and I love working with young adults, especially all of you, because all of you remind me of myself when I was a student, because I started off at CCAC as well. So it was just exciting to see everybody learning and everything. So, all right, now that I got that off my chest, let's do this. Let's do this last section. We'll finish the semester off strong. Okay. Remember, I'm always available if you have questions or stuff like that. If you have concerns and you want to actually talk to me, so we can always set up a Zoom appointment. All you got to do is email me to let me know when you're available. Other than that, let's get started, shall we? So, 7.3, square roots and the Pythagorean theorem. Okay, so first I'd like to identify, what exactly is the square root of a number, okay? So, as you can see here, the square root, which is this crazy symbol right there, okay? Which is this crazy symbol right here. All right, so the square root, which is denoted with that symbol, of a number, A, is the positive number B whose square is A. All right, now, it's a lot of math jargon, so here's what I'm talking about. All right, if the square root of A equals B, all right, I'm going to change this, then B squared equals A, okay? And a little side note, the square root of 0 equals 0. So let's see what this means. Let's just do some examples, all right? And here's the best part, all right? You already know the answers to these questions because you already know what I'm going to ask. So for example here, the square root of 49 equals 7. Why? Well, because 7 squared equals 49. So what I'm going to do in red here, all right, is I'm going to point to everything in the definition above. There's A, there's B, which means B squared has to equal A. Does that make sense? Let's look at another one here. Let's look at another one, all right? How about the square root of 4? Well, the square root of 4 equals 2 because 2 squared equals 4, okay? Let's try another one. The square root of 25 equals 5 because 5 squared equals 25, okay? Now, we don't have to stop here. We can actually apply this to problems that you and I don't know about it. I love them myself. I know you hate them, but that's okay. That's okay. How about this? How about the square root of 136? Well, the square root of 1 over 36 is going to be 1 over 6 because 1 over 6 squared equals, and I'm going to write it out, it equals 1 over 6 times 1 over 6. And we know to multiply fractions, we go straight across. So 1 times 1 is 1, and 6 times 6 is 36. Okay? Let's try another one like that. How about, what are two numbers I didn't try yet? How about this one? 9 over 100. Well, the square root of 9 over 100 equals 3 over 10 because 3 over 10 squared equals 3 over 10 times 3 over 10. And 3 times 3 is 9. 10 times 10 is 100. Okay? So I hope that makes sense. All right? Now, these are very, very nice numbers because they always worked out. Okay? But now the question becomes this. Okay? Now the question becomes this. All right? We're going to learn how to approximate a square root. All right? And what I mean by that is this. Okay? What I mean by that is this. We know that the square root of 1 equals 1. All right? And that's because 1 squared equals 1. All right? We also know the square root of 4 equals 2 because 2 squared equals 4. All right? We know that. Here's the question. What is the square root of 3? Okay? Now, since we are approximating, all I want is just an approximate answer. You don't have to be specific. But what you do have to do is you have to be able to justify your solution. So let's look at it like this. Here's a number line. I'm going to put a 0, 1, 2, 3, and 4. Okay? All right? Now, here's what we know. We know the square root of 1 is 1, so I'm going to put it directly above. And we know that the square root of 4 is 2, right? Oh, wrote that incorrectly. Is 2. And I'm going to write that above, okay? The square root of 3 is definitely going to be in between these two numbers, square root of 4 and the square root of 1, all right? The question becomes, where is it? Well, if you think about this, okay, 3 is a little bit closer to 4 than it is to 1. So what I'm going to say is that the square root of 3 has to be somewhere around there. In other words, it has to be, so the square root of 3 has to be in between, all right, got to be in between 1 and 2, where our best guess is that it is closer to 2 because, let me write out the word because better. The square root of 3 is closer to the square root of 4. Okay? All right? That's really all I'm looking for. Okay, so the square root of 3 has to be in between 1 and 2. All right? And our best guess is that it's closer to 2 because the square root of 3 is closer to the square root of 4. Now, just to show you, the square root of 3, if you use a calculator, is approximately 1.73, which is definitely close to 2. Okay? So we can actually use that knowledge to our advantage, all right? For example here, what is, let's see, estimate the square root of, let's say, 78, okay? So this is our example here. So we need to estimate the square root of 78. How do we do that? You want to pick square roots that you know. For example, We know the square root of 4 equals 2. We know the square root of 25 equals 5. We know the square root of 36 equals 6. We know the square root of 81 equals 9. Why? Because, and I'm going to go all the way back up here, because it all goes back to this definition right here that I'm circling, or that I'm blocking in right now, okay? Notice all the examples I picked, 49, 4, 25, 1 over 36, 9 over 100, they were all what we call perfect squares. Perfect square meaning that the number itself, the number times itself is going to equal some result. 3 times 3 is 9. 7 times 7 is 49. 25, or 5 times 5 is 25, okay? So what we're going to do, all right, is we're going to pick a perfect or two perfect squares that are really close to the square root of 78, okay? So if you think about it, we have the square root of 64. Well, that's going to be 8. And then the next one is going to be the square root of 81, which is 9, okay? So we know the square root of 78 is going to be in between. It's going to be somewhere in between 8 and 9 because the square root of 78 is in between the square root of 64 and 81. The question becomes this. Where is it? Is it closer to 8? So is this closer to 8 or is it closer to 9? Well, if you think about it, okay, 78 minus 64 is a difference of, well, 8 minus 4 is 4, 7 minus 6 is 1, so that's a difference of 14, okay? And then 81 minus 78, okay? 81 minus 78, well, that's a difference of 3. So I already know that the square root of 78 is going to be closer to 9 than it is 8. All right? In fact, it's going to be really close. Okay? It's going to be really close to 9. Okay? So, let's write out a little statement saying that. All right? So, since 78 is closer to 81, then the square root of 78 is closer to the square root of 81. All right? And just to show you, if you use a calculator, if you were to guess, if I were to guess, I would guess this is going to be about 8.8 or 8.9 because it's so close. All right? So let's see here. The square root of 78 is approximately, if you use a calculator or if you use like Google, you can even ask Siri if she knows what the square root of 78 is, and she'll tell you. It is 8.83. So there's my guess. I'm pretty close. Okay? All right. Now, we get to the last topic. This is it. Nothing more after this. Okay? So what we're going to talk about is the Pythagorean theorem. Okay? Now, the Pythagorean theorem says this. If A and B are the lengths of A, let's say this. If A and B are the lengths of the legs of a right triangle, and don't worry, I'll explain all this, and C is the length of the, big word, hypotenuse, then, and here's the biggie, A squared plus B squared equals C squared. Okay? Now, let me draw you a picture. So, there's a right triangle. And what makes this a right triangle is the fact that you have a right angle right there. That's called a right angle, okay? And a right angle is equal to 90 degrees, okay? So it's a right angle, all right? Now, when it says if A and B are the lengths of the legs, this is A and this is B, which means this is a leg and that is a leg, okay? And when you draw these, you always want to make it look like this, okay? Just helps. Now, the longest side is called your hypotenuse, and that's going to be right here, all right? All right, so I'm highlighting it in blue. All right? So this is C, and this is your hypotenuse, okay? And the hypotenuse is always on the opposite side of the right angle. Always, okay? So right here is your right triangle, and the Pythagorean theorem says that if you were to take the first leg, leg A, and square it, and then you add it to leg B and square it, that is going to equal length C squared. So let's look at a really, really easy example, okay? Let's look at a really, really easy example. So if A equals 6 and B equals 8, find C. Okay? All right, find C. So here's what we know. We know that if we were to draw this picture, all right, that's going to be 6 and that's going to be 8. We have to find C. So according to the Pythagorean theorem, A squared plus B squared equals C squared. All right, we're going to go ahead and make the substitutions. 6 squared plus 8 squared equals C squared. Well, that's going to be 36 plus 64 equals C squared. Now 36 plus 64 is 100 equals C squared, which means C equals 10. Now, how did I get that? How did I just know C squared equals 10? Well, what we would do is take the square root of both sides. Okay? We're going to take the square root of both sides. Now, whenever you do that, there is one little special thing. You have to put a plus or a minus, okay? So let me block this in and let me write it down here, okay? So I'm going to rewrite it and I'm going to explain it, okay? We have to remember, all right? We have to remember that, I guess I don't need a comma there. I don't know. We'll find out. Remember that 10 squared equals 100 and negative 10. Remember, it's in parentheses. Negative 10 squared also equals 100. So when I go ahead and watch what I write here, watch what I write. I'm going to write 100 equals C squared. As soon as I do this, and I'm going to do it in blue. As soon as I do this and this, with the number, I have to put the plus or minus, okay? Now, here's what's nice, okay? We don't have to worry about, let me get out my red marker, sorry. We don't worry about the negative answer, all right? And that's because we are measuring the length, okay? And we know that lengths cannot be negative, okay? Lengths are not negative. So we just include the positive side, okay? And that is why C equals 10. That's how I got that, all right? It's a beautiful thing. I want to show you something pretty interesting, okay? All right. If you think about this example here, we're going to let A equal 3 and B equal 4. Let's find C, okay? Now watch this. I'm going to draw you a picture, okay? All right. Here's my right angle, okay? Actually, let me give myself some space. You'll see why in a second. I'm going to do it down here. So here's my right angle. Here's 3. There's 4. The question becomes, what is that length right there? And there's a reason why I wrote the numbers on the inside. We know with the Pythagorean theorem, a squared plus b squared equals c squared. So we get 3 squared plus 4 squared equals c squared. We know that this is going to be 9 plus 16 equals c squared. 9 plus 16 is 25 equals c squared, which means c equals 5, okay? Because I went ahead and did that square root thing. So I know this is 5 right here, all right? Now watch this. I know this length right here. Let me use a different color. We'll use red for this one. I know this is 3, okay? We also know that if we were to square 3, that is, so let me write this here. If we were to square 3, that means 3 times 3, correct? And if, watch this, I'm going to draw a square where I have 3 blocks per side. So this is a 3 by 3 square with 1, 2, 3, 4, 5, 6, 7, 8, 9 total blocks, or 3 squared equals 9. Okay? So far I have 9 total blocks. Now I'm going to just erase those numbers on the inside because we really don't need them. All right? Now watch this. In a different color, let's say blue, I know this length right here. Okay? I know that length is 4. So what I'm going to do is draw a square. Oh, that's a horrible square. There we go. That's a little bit better. I'm going to draw a square where I have 4 blocks per side. Okay? So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or 16 total blocks, right? So 4 squared equals 16. All right, now I don't need those numbers in there. All right, you'll see why in a second. There we go. So I think that's as best as I'm going to get. Now watch this. Let's do this in green. We know this right here. All right, it's going to be another square. Okay, except this one is going to have 5 blocks. All right. Sorry, I know this is not graph paper, so it's not perfect, but you get the idea. Let's count these blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Now, I'm going to fill in my blocks in the other 2 squares again. Except this time, I'm not going to stop counting, and watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. In other words, if you were to draw squares and just count up the number of squares in this length and the number of squares in this length, it will always equal the number of squares try to get out a highlighter. It will always equal the number of squares in the hypotenuse. Always. Always, always, always. That is just one of those formulas that you're going to learn, and it will stick with you forever because it's so easy to memorize, and then the application of it is really easy to demonstrate how this actually works, okay? That's it. We're done. The semester is over. Again, I commend all of you for all of the hard work. This semester has not been easy in the slightest. All right? As my dad would say, the deck of cards were definitely stacked against us, but we made it through it. All right? At the very beginning of the semester, I don't know if you remember this, but at the very beginning of the semester, my ultimate goal was to get you to love math. All right? I mean, that would be great, but I know that's not always going to be obtainable for everybody. But the goal that is obtainable was I wanted everybody to be able to look back on this semester and go, you know what? I may not love math, but I know I can do it. And I have nothing but confidence in all of you. You're all very smart individuals, okay? What it boils down to is, are you willing to sacrifice and put the time in to learn it? All right? You are all capable of succeeding whatever it is you want, okay? So just remember, I'm always in your corner. I'm always available if you need to talk, you know? And I hope that you look back on this semester and go, you know what? It wasn't bad. Professor Float was kind of loud. He was animated at times. But, you know, he really cared about, you know, what I needed out of this class. And like I said, all I wanted you to be able to do is look back and say, I can do it. All right? I hope that we get to be able to see each other before the semester ends. If not, just know that, you know, you can always say hi to me or email me outside of class. And I will talk to you sometime soon. Good luck with whatever it is you want to do with your life. All right? I'm in your corner. Remember that. Have fun. Enjoy. I'll see you later. Bye-bye.